Hey everyone, and welcome to RUBIN'S Mind Lab, where we break down the latest research into what it really means. Ever wondered if listening to special sounds can actually make you smarter or more focused? Well, get ready, because today we're diving into a study that puts that idea to the test. This is a big one. For years, people have been told that listening to what are called binaural beats can boost your brain power, help you focus, or relax you. You can find them everywhere online, promoted by neurohackers and influencers. But what if the science doesn't back up the hype? That is exactly what this research set out to discover. So, what is the big idea behind binaural beats? Imagine listening to two slightly different sounds, one in each ear. Your brain, instead of hearing two separate sounds, perceives a third phantom beat at a specific frequency. The theory is that this phantom beat can encourage your brainwaves to sync up with it, leading to changes in how you feel or think. People often recommend specific frequencies for different goals, like theta waves for relaxation, alpha for creativity, and beta waves for focus and problem solving, especially for demanding work like studying or doing complex tasks. But here's the catch. While scientists know about the psychoacoustics phenomenon of binaural beats, the evidence that they actually work for cognitive enhancement is really mixed. Some studies show effects, while others find nothing or suggest that any perceived benefit might just be from believing it will work, the placebo effect. The authors of this paper point out a crucial difference. Lab studies are one thing, but using binaural beats at home while you are trying to study or work is quite another. That is the real-world scenario often promoted, and it is what they wanted to test. Their previous study, called HUBS, tried this out with about 1,000 people. They found that listening to binaural beats actually seemed to impair cognitive performance rather than boost it, and there was a lot of variation between people. Some got worse, some didn't change, and a few even seemed to improve. But the big question was, why the difference, and would this negative effect hold up in a bigger study? That is where this current study comes in. They decided to replicate and expand on their previous work with a much larger group, nearly 2,000 adults. They wanted to see if the impairment they found before was real, and if they could figure out why some people might be affected differently than others. So, how did they do it? Imagine you are trying to do a challenging puzzle, a bit like an IQ test, that involves figuring out patterns. That is what they had participants do. They were split into 3 groups. One group listened to 15 Hz binaural beats, another to 20 Hz binaural beats, and a third group listened to a single pure tone, which acts as a control basically to see if just listening to any sound makes a difference, or if it is specifically the binaural beat. Crucially, the participants didn't know which sound they were listening to, making it a single blind study. They did the puzzle task twice. The first time was in silence to get a baseline of their performance. Then, after a break, they did it a second time while listening to their assigned sound. They also collected information not just about demographics like age and gender, but also psychological factors like how tolerant people are of ambiguity, how much they tend to ruminate or overthink things, and how much they reflect on themselves. And what did they find? Well, it is not what the hype would have you believe. Both groups listening to binaural beats showed a small decline in their puzzle performance, compared to when they were in silence. The group listening to the pure tone control, however, didn't show this decline. To put it simply, when they looked at the average results for each group, the binaural beat listeners performed a little worse on the second try compared to the first. The group listening to the pure tone did pretty much the same. It wasn't a huge drop, but it was consistent across the binaural beat groups. Now, remember that variability they were trying to explain. They looked at the psychological factors. They measured tolerance of ambiguity, rumination, and reflection to see if they could chunk people into different types of listeners. They found 3 distinct profiles based on these psychological traits and age. One profile was younger and tended to ruminate more. Another was older with lower scores on rumination and reflection. The third was young adults with high tolerance for ambiguity and reflection. However, here is the twist. Even though these profiles seem to capture different kinds of people, they didn't explain why some people's performance dropped with binaural beats and others didn't. The performance change was pretty much the same across all these different profiles. So, if the psychological profiles didn't explain the differences, what did they also look at whether the changes were reliable? This means, was the change in performance bigger than what you'd expect from just random variation or measurement error? They found that most people, about 93.5%, showed no reliable change. A small number, about 5%, showed a reliable decrease in performance. And an even smaller number, about 1.4%, showed a reliable increase. So, yes, a minority did get worse, but it was a small minority. And again, the psychological traits like rumination or tolerance for ambiguity didn't explain who fell into the reliable decrease group. The only thing that seemed to matter was their starting performance. Those who were already scoring higher on the puzzle test were more likely to see a decrease, though this might partly be due to statistics, like regression to the mean, where extreme scores tend to move closer to the average over time. The key takeaway here is that the psychological factors they thought might explain individual differences just didn't. What does all this mean? It means that the exciting claims about binaural beats being a cognitive enhancer for everyday tasks just don't hold up in this large-scale study. For most people, listening to them while working or studying does nothing. And for a smaller group, it might actually make their performance a little worse. This study is a pretty strong signal that the hype around these consumer neurotechnologies is way ahead of the actual evidence. It is readily available, cheap, and easy to use, but it doesn't seem to deliver on its promises, and might even be counterproductive for some. This raises an interesting point about regulation, since these are just audio files. They often fall through the cracks of regulations that focus on hardware-based brain stimulation. The authors suggest that platforms hosting this content and the influencers promoting it should really consider the evidence. They point to new regulations like the EU's Digital Services Act, which holds platforms accountable for systemic risks, including mental well-being. While there are standards for visual content to prevent seizures, there isn't yet a standard for auditory content that could be harmful in other ways. They argue that as more research like this comes out, there needs to be a discussion about how to label, amplify, or even restrict access to these types of technologies, especially for vulnerable groups. Now, no study is perfect. The researchers acknowledge that because their puzzle test had a limited scoring range, it might have been hard to register a decline in people who were already scoring very low. Also, running an experiment online has its challenges. They couldn't perfectly control the headphones people used, which might have slightly weakened the binaural beat effect for some. They also point out that they only looked at a few psychological factors, and there could be others, like personality traits or even how well people sense their own body's internal state, that might play a role. Finally, this study looked at a single session, and we still don't know what happens with long-term use. So, to wrap it all up, this research suggests that the popular practice of using binaural beats at home to boost your cognition is not supported by evidence. It doesn't help for most people and may even slightly harm performance for some, without a clear explanation for who is affected and why. This highlights a gap between the marketing of these neurotechnologies and scientific reality, and it calls for more rigorous research and better governance. What do I think? This is a really important study because it tackles a widely used practice head-on with a large sample size and robust methods. The lack of explanation for individual differences is frustrating, but also a sign that our understanding of how sound affects the brain, especially in complex, real-world settings, is still developing. It definitely makes me pause before recommending binaural beats for focus or productivity. It seems like we need to move beyond the simple listen to this frequency advice and potentially towards more personal, adaptive approaches if sound stimulation is to have real benefits. Future research looking at a wider range of cognitive tasks and psychological factors, perhaps even in more controlled lab settings with advanced brain imaging, could shed more light on this. What are your thoughts on binaural beats? Have you tried them? Did they work for you? Let me know in the comments below. And if you found this breakdown helpful, give this video a like and subscribe to RUBIN'S Mind Lab for more science explained simply. Thanks for watching, and I'll see you in the next one.